Hello everyone. How are you all? Good evening to everyone. I hope that all of you are doing good and be at a great pace in terms of health and all. So today we are going to discuss about the alternating current, and since it's a revision session, so we will be moving like a conceptual manner, and then after we will solve some questions. Okay. So the very first concept that would be very important by the point of view of this chapter or the examination that we are currently seeking in is series LCR circuit. Now, first of all, we should understand that what is an LCR circuit. So it's a combination of resistor, inductor, and capacitor, okay, in which an alternating source of voltage is being applied. This is the alternating source. So in this circuit, if we will talk about this circuit specifically, we will have an impedance in place of resistor. We will have an impedance which is denoted by Z, and Z is nothing but it's R plus XL plus XC, okay? Which means Z is the combined resistance offered by this series LCR circuit, okay? यहाँ पे Z को लेकर के कुछ बातें हैं जो मुझे बतानी है। चलो इस पॉइंट पे बाद में आएंगे. फर्स्ट ऑफ ऑल वी विल डिस्कस व्हाट इज Z. Z is the impedance of the circle. Impedance, which is given by square root of R square plus XL minus XC or XC minus XL whole square. This denotes the resistance provided by the series LCR circuit. ठीक है? In impedance triangle, we will show this like this: XC minus XL. This is R, and here it is Z. The hypotenuse of this triangle is Z, R square plus XL minus XC whole square. This angle is phi. Specifically, it is written as phi. But phi here is nothing but the, if we calculate cos phi here, cos phi is nothing but the R upon Z, or in terms of LCR circuit, it will be R square into XL minus XC whole square. This is nothing but the power factor. It tells us about that how much power is consumed in the circuit. ठीक है? अब यहाँ पे मैं बात कर रहा हूँ XL और XC की. XL is nothing but the impedance of a purely inductive circuit. XL का वैल्यू होता है ओमेगा L. This is the as a type of resistance offered by the inductor. It is given by omega L, and XC is the resistance offered by the capacitor. So it is 1 upon omega C. So the condition that we are discussing there is this: if XC is greater than XL, so definitely जो impedance होगा वो will be capacitive, because circuit will behave as a capacitive circuit. क्यों? क्योंकि if XC is greater than the value of capacitor is being increased, which means the circuit will behave as a pure capacitive circuit. तो उस केस में क्या होगा कि जब ये प्योर कैपेसिटिव सर्किट की तरह बिहेव करेगा, ठीक है, तो सारी कैलकुलेशन कैपेसिटिव सर्किट के अक्रॉस ही होंगी. ठीक है ना? वी विल अज्यूम इट as a pure capacitive circuit, and then we will do all the calculation. But if XL is greater than XC, then the circuit will behave as a pure inductive circuit. ठीक है, इंडक्टिव सर्किट की तरह ये बिहेव करेगा। ये ऐसा हम क्यों बोल रहे हैं, तो इसके लिए आपको फेजर डायग्राम देखना पड़ेगा। सपोज मैंने वी आर ली, वोल्टेज अक्रॉस द रेजिस्टर, तो इसी डायरेक्शन में मेरा आई आर आएगा। ठीक है, क्योंकि करंट और वोल्टेज क्या होते हैं, सेम फेज में होते हैं इन प्योर कैपेसिटर प्योर रेसिस्टिव सर्किट। यहाँ पे दो प्लेन और बना लेता हूँ 90 डिग्री पे, this. But we know that the voltage across a capacitor or across an inductor, the voltage across a capacitor will be leading the current by 90 degree, and voltage across the inductor will voltage across the capacitor will be lagging from the current by 90 degree, and voltage across the inductor will be leading the current by 90 degree. Okay? So based on this data, if you will see here, if XL is greater than XC, तो हमारा जो वोल्टेज ड्रॉप होगा एक्सेल की तरफ, अक्रॉस द वोल्टेज ड्रॉप अक्रॉस द इंडक्टर, वो इंक्रीज हो जाएगा। तो जो नेट रिजल्टेंट मेरे पास जो बनेगा वो ऊपर की तरफ है, विच इज नथिंग बट वी एल माइनस वी सी। तो इस केस में ये क्या बिहेव करेगा, इंडक्टिव सर्किट की तरह बिहेव करेगा। ऐसा क्यों बोला, क्योंकि वोल्टेज अक्रॉस द इंडक्टर वी एल इज इक्वल टू आई इंटू एक्सएल। आई एक्सएल सीरीज सर्किट है तो आई एक्सएल, अब अगर एक्सएल ज्यादा है तो वी एल भी ज्यादा होगा। वीसी क्या लिखूंगा, आई इंटू वी, आई इंटू डॉट हटा के मैं ऐसे लिख देता हूँ आई एक्सएल, एंड दिस इज आई एक्ससी। So if XL is greater than XC, we can say that VL is greater than VC, or XL is greater than XC. इसलिए ये इंडक्टिव सर्किट की तरह बिहेव कर रहा है। एंड इफ VL is less than VC, देन ये बिहेव करेगा XL किसकी तरह बिहेव करेगा, कैपेसिटिव की तरह बिहेव करेगा। एंड वी कैन से दैट XC इज ग्रेटर देन XL इन दिस केस। ठीक है, क्लियर हुआ, यहाँ तक की चीजें क्लियर होनी चाहिए। उसके बाद अगर XL XC की इक्वल हो जाता है, उस केस में क्या होगा, जो मेरा इम्पिडेंस है Z, विच इज गिवन बाई स्क्वायर रूट ऑफ आर स्क्वायर प्लस XL माइनस XC का होल स्क्वायर। अब अगर XL XC की इक्वल है तो ये टर्म जीरो हो जाएगा, which means Z will attain its minimum value, which is nothing but the R resistance। ठीक है, तो यहाँ इस कंडीशन को हम क्या बोलते हैं, रेजोनेटिंग कंडीशन, और रेजोनेंस इन एलसीआर सर्किट। तो रेजोनेंस इन एलसीआर सर्किट तभी पॉसिबल होगा व्हेन XL is equals to XC, and similarly we can say I will be maximum in this case and Z will be minimum। जब इम्पिडेंस मिनिमम है तो करंट तो मैक्सिमम हो गई, if the resistance is minimum then current will be maximum। तो यहाँ अगर आप करंट और फ्रीक्वेंसी का ग्राफ ड्रॉ करोगे तो इट विल बी गिवन लाइक दिस, which means there is a particular frequency for which you will having the maximum value, and that frequency is nothing but the resonating frequency, resonating frequency। इसकी वैल्यू इजीली फाइंड आउट कर सकते हैं, XL is equals to XC, then omega L is equals to 1 by omega C। For this value, this omega will become omega naught, so it is omega naught square is equals to 1 by LC। Now omega naught को we can write as 2 pi f naught 1 upon square root of LC, यहाँ से एफ नॉट का वैल्यू आपको मिलेगा 1/2 पाई स्क्वायर रूट LC. So for this particular frequency, current will be maximum in the series LCR circuit. ठीक है, इसमें आप ये दो इंपॉर्टेंट टर्म है, शार्पनेस ऑफ रेजोनेंस. शार्पनेस is nothing but the width between any two values of angular frequency or the frequency itself. So this bandwidth is nothing but the sharpness. तो sharpness क्या है? डेल्टा ओमेगा इज इक्वल टू R/2L. ठीक है, इट्स ω1 माइनस ω2 एक्चुअली. So it's R/2. Now Q is nothing but the ratio of resonating frequency to the twice of sharpness of the resonance or bandwidth. This is also termed as angular bandwidth. Angular bandwidth. So this is omega into L by R. This is termed as the quality factor. ठीक है, आई होप कि इतनी बातें आपको समझ में आई होंगी. नाउ पावर अक्रॉस दिस LCR सर्किट. तो पावर के लिए सिंपल सिंपल सा फॉर्मूला है, पावर इज इक्वल्स टू, देखो, we always calculate power as V into I, but here we will calculate power average. So power average will be VRMS IRMS into cos phi. Got it? So this is power. Now पावर के बारे में मैंने बात कर ली. एवरेज पावर इज गिवन बाय VRMS IRMS into cos phi, where cos phi is the power factor of the circuit. Okay. For pure resistive circuit, pure resistive circuit, pure resistive circuit. Okay. So pure resistive circuit में आपको सिर्फ और सिर्फ रेजिस्टेंस ही मिलेगा. ठीक है, उस केस में if we will discuss that what is the power, then how to calculate that. So we know that in pure resistive circuit, the voltage and the current are in the same phase. Okay. What we can say, in pure resistive circuit, voltage and current are in the same phase. So if they are in same phase, like this is the voltage line, so this is also the, in the same direction we have the current line. the angle between them will become 0. So here we can say that phi, which is nothing but the cos phi, the angle that we require to calculate the power factor, that will become 0 degree. Okay, because there is no phase difference. If there is no phase difference, then phi is 0, because this phi denoting the phase difference between two circuits, between two oscillating quantities. So in pure resistive circuit, if I'm writing the voltage as Vm sine omega t, then current will also look like Im sine omega t. So if you check here, this is the phi 1, this omega t, this is phi 2. So phi 1 minus phi 2 will become 0. So there is no phase difference in the current and the voltage. Now if phi is 0, then we can say the average power, which is nothing but Vrms, Irms, cos phi. Phi will become 0, so cos phi will become 1, which is the maximum value of it. If it is maximum, we can say the power consumed in pure resistive circuit is the maximum power. तो resistive circuit जो है ना वो maximum power consume करता है, consumed maximum power. Okay. While at the same time, if we talk about purely inductive or capacitive circuit, so for purely inductive or capacitive circuit, for purely inductive and capacitive circuit, we know that the phase difference between voltage and current is pi by 2. Pi by 2. So if it is pi by 2, then we can say that power average will be 0, which means there is no power consumed in the circuit, but current is flowing. Although the power consumed is 0, the power consumed is 0, but current is flowing. So that value of current, that particular current is termed as wattless current. Wattless current. ठीक है, यहाँ तक सभी को क्लियर हो गए थे. Now we talk about the choke coil. What is choke coil? So a choke coil is nothing but the an inductor of small resistance. Small resistance. Okay. So this device is used to control the current. It is used to control the current in AC circuit. ठीक है, without wasting too much of power. Why? Because this is a inductor circuit. इंडक्टर है, तो इंडक्टर क्या करो, जो भी करंट फ्लो करेगा दैट वुड बी इन द लीडिंग फेज. सॉरी, ठीक है, दैट वुड बी इन द lagging phase by pi by 2. The phase difference between the current and the voltage will be pi by 2. So we can say that power average here will be 0 because cos pi will be 0. So power assumed will be minimum. Although it is not 0 because coil also have its resistance, on resistance, because it is kind of made up of some material. Na? So that's why it possesses a very small value of resistance. Okay. But in spite of using resistor, we would use choke coil in AC circuit without too much power consumption. Okay. Here the cos phi is given by R by Z, and since this is an inductor only, so it will be R upon square root of R square plus XL square. This is the choke coil. Now, what less current I have told you. Now just try to solve this question. Before starting this question, let's just discuss the transformer here only. Transformer. So transformer is a device which we use to step up or step down the voltage. It's an AC device. Okay. So in transformer, the principle that is working on is mutual induction basically. So transformer is working on is an AC device which is used to transform voltage from one to another of greater or smaller value. We use this transformer to increase or decrease the value of voltage, and likewise current, greater or smaller value. Okay. This is the outlet structure of this transformer. Here we have some coils wounded up on two limbs of it. One of the limb is termed as primary limb. This is the primary, and this is secondary. So one of the limb is primary winding, and on the second one is secondary winding. So there is a relation here for that voltage across the secondary winding divided by voltage across the primary winding is equals to EMF across the secondary divided by EMF across the primary will be equals to number of turns in the secondary divided by number of turns in the primary. So this is the relation that we use to calculate voltage on primary or rather on secondary. Okay. Now, this relation can further be extended as IP upon IS, IP upon IS is equals to VS upon VP equals to NS upon NP. Okay, there is a special type of transformer in which you will find the winding at the center like this. So this is termed as the center tapped transformer. ठीक है. अब यहाँ से there are two types of transformer based on the uses of it. First one is step up transformer, which increase the value of transfer this voltage, which means for that voltage across the secondary, this is stepping up, the voltage across the secondary will be less than, sorry, this is stepping up ना. So step up के लिए secondary जो voltage है, यहाँ output है, this is the output and this is the input. ठीक है. तो secondary पे जो output आपको मिलेगा that would be greater than the primary winding because it is stepping up the voltage. So V secondary will be greater than VP. So we can say N of secondary should be greater than N of primary. And for that, I of primary will be less than, sorry, I of primary will be greater than I of secondary. Now, second type of transformer is step down transformer. Step down transformer. For that, we know if it is decreasing the value, which means voltage that we get at the secondary will be less than the voltage across primary. So number of turns of winding of secondary will be less than the number of turns of primary, and so on. IP will be less than IS. Got it? So these are the specification. Apart from that, transformer will not work. The practical transformer will not work at the 100% efficient. So there are some losses also. These losses is termed as the flux leakage. That is an important loss. Flux leakage, eddy current formation, resistance of the winding, and hysteresis. So these are the primary losses that we can have in the transformer that decrease the efficiency of the transformer. Okay. Now let's just move on along this question. The question stands that when a coil is connected across a 20-volt DC supply, it draws a current of 5 ampere, and when it is connected across 20-volt 50 hertz AC supply, it draws a current of 4 ampere. The self-inductance of the coil is. To solve this question, firstly we should write what is given to us. So when it is connected to the DC supply, we can apply the Ohm's law. V is equals to IR as it is. So V is nothing but 20 volt. I, we 5 ampere. And resistance then it provided by it will be 4 ohm. Okay. Now this is for the DC. For DC. Now for AC, we know that whenever the AC will apply, the circuit will be providing a impedance, ठीक है, in the pathway of current. So we can say that V is equals to I into Z. So V is nothing but 20. This is the value written as RMS value itself. Always remember. So V is 20. I is nothing but 4 ampere. This is also the RMS value into Z. Z will become 5 ohm. Now we know that Z is nothing but square root of R square plus XL square is equals to 5. So from here, if you will square root of it, it will become R square plus XL square is equals to 5 square, which is 25. R square is nothing but 4 square, which is 16. So XL square will become what? 25 minus 16, which is nothing but 9. That's just the mathematics now. XL will be 3. Now, XL is not the self-inductance. Further, we can write XL as omega into F, omega into H. Now, this L is the self-inductance equals to 3. Now, omega is nothing but 2 pi into F. The frequency that is measured in hertz is the linear frequency. Okay. So, 2 pi F into L equals to 3. Now 2 into 3, as it mentioned that take pi is 3. So we have taken 3 into F is 50, L 3. 3 and 3 will cancel out, L will become 1 upon 100. So if we multiply it, like we can say that it is 10 raised to the power minus 2. If we multiply it with 10 raised to the power minus 1 and divide it with the same, so it will be like this. We can write it like that. So 10 into 10 raised to the power minus 3. Why we are doing it? We are converting it into millihenry. So it will be 10 millihenry. Okay. Now this is answer is 10. Now this one, for a given series LCR circuit, it is found that maximum current is drawn when value of variable capacitance is 2.5 nanofarad. If resistance of 200 ohm and 100 millihenry inductor is being used in the given circuit, the frequency of the AC source is, अब देखो सीरीज एलसीआर सर्किट अभी हमने डिस्क्राइब किया था. इट इज फाउंड दैट द कीवर्ड मैक्सिमम करंट. तो मैक्सिमम करंट कब ड्रॉ करेगा? व्हेन द मैक्सिमम पावर विल बी कंज्यूम्ड, एंड मैक्सिमम पावर विल बी कंज्यूम्ड व्हेन cos phi will be 1, and cos phi is nothing but r by z. ठीक है. So we can say I will be I max when cos phi will be 1. So we can say R is equals to Z. Clear? Now, as we know, this is R equals to Z will become square root of R square plus XL minus XC whole square. Okay? Now, if you square root of it, it will become R square is equals to R square plus XL minus XC whole square. This is the one of the method. यहाँ से R square will cancel out. Then you can say XL is equals to XC. Now the second method is that in series LCR circuit, the maximum current will be drawn when there is resonance. So this is resonance. You can use the concept of resonance here. So resonance circuit. In resonance circuit, we can say directly that XL is equals to XC, which means omega will be square root of 1 upon L into C. Omega ko we can write 2 pi F square root of 1 upon root LC. Now F will become 1 upon 2 pi square root L into C. 1 upon 2 pi. L का value is already given 100 millihenry. 100 into 10 raised to the power minus 3. convert it into the SI units, and capacitor is given as 2.5 into 10 raised to the power minus 9 farad. We have converted nanofarad into farad. So if you will see here, this will become 2 pi square root of, this will become 10 raised to the power minus 12, and it will become 250. We can write it as 20 into 10, 10 raised to the power minus 12. So from the square root, it will be coming out as 5 into 10 raised to the power minus 6 into square root of 10. But square root of 10 is nothing but pi square. Sorry, pi square is given as 10. So pi will be nothing but square root of 10. We can write in place of that as pi. It will become 1 upon 2 pi square, or 2 को you can multiply here, so it will become 10 into 10 raised to the power minus 6, which is nothing but minus 5. You can take this minus 5 above, 10 raised to the power 5, and below pi square will become 10. So ultimately we can say this will be 10 raised to the power 4, but answer is given in the multiple of 10 raised to the power 3. So we can say 10 into 10 raised to the power 3. Here the answer is 10. Okay. So I hope you got it. Now, this one, in series LCR circuit, the capacitance is changed from C to 4C. To keep the resonant frequency unchanged, the new inductance should be. We want the resonantic frequency same for both the values. So omega 1 is equals to omega 2. Now omega 1 के लिए 1 upon root L1 C1. Got it? Now if you will see, it will become square root of L1 C1 is equals to square root of L2 C2. Taking up the square, L1 C1 is equals to L2 C2. Now for L1 is equals to L, let's suppose, initial value. Okay, C1 is C, but L2, C2 will become 4C. So we can say L2 is nothing but L by 4. To keep the resonant up, someone of you will choose this, but the answer is given in terms of change. It is not asking you the final value, it is asking you the change. So initially it was L, and finally it is become L by 4. The change here will be 3L upon 4. So that is the answer. This inductance will be reduced by 3 by 4 times of L. Okay. So this is it for today's class. I hope you will enjoy this session. If you have any kind of doubt, you can connect to me. Thank you so much for being attentive and being responsive. Bye bye. Take care.